Hi everyone, my name is Gian-Luca Savino and I'm a PhD student at the University of St. Gallen. Today I will tell you about my paper on improving agent-based route predictions for as the crow flies navigation. Let's jump right in. Many people rely on mobile navigation technologies for their everyday commute, leisure trips, and generally for getting from A to B. These technologies often use turn-by-turn instructions for in-car navigation systems and navigation apps on smartphones or standalone navigation devices. However, in the field of cyclist navigation, the trend is moving towards other navigation methods. One example is the as the crow flies navigation method. This method provides users with a constant indication of the direction to the destination. Given such information, users will follow this direction as closely as possible. This navigation method, however, comes with some problems or drawbacks that have been discovered in related work. They include users ending up in dead ends because they didn't know what was ahead, and not knowing when to take a turn because the seemingly best street is not so easily recognizable. In this paper, we try to circumvent these problems by predicting users' potential routes with as the crow flies navigation. Because if we can predict their route accurately, we can react or prevent such navigation errors. Existing methods to predict these routes use heuristics like the least angle strategy, which says that humans will always choose the street which has the least angle deviation to some destination. However, a human might not even realize the difference between a 20-degree and a 23-degree angle and thus can't choose the least angle accurately, potentially choosing a suboptimal path for the navigation. So how can we imitate this uncertain behavior for our prediction? We designed a study to test how accurate humans were able to interpret these angle situations. We showed 64 participants different situations with as the crow fly navigation instructions, like on this picture here. Participants then had to decide which street to turn into given these instructions. We found that the smaller the angle, the lower was the accuracy of choosing the correct street. From our results, we were able to extract a function describing the correctness of answers given a certain angle deviation difference. We implemented this function into an agent which would now make navigation mistakes based on how uncertain it is. To test whether this uncertainty agent finds routes that are closer to actual human wayfinding behavior with as the crow flies navigation, we compared the data of a standard least angle agent and the uncertainty agent with actual human experiment data. We found that the uncertainty agent covers 15.5% more of the human route compared to the classical least angle agent. Thus, we conclude that the uncertainty agent makes some of the mistakes that humans also made in a previous experiment and is better at predicting their routes. Interpreting angles is, of course, only one aspect of improving agent-based route predictions for as the crow flies navigation. And with this publication, we contribute a first step in this direction. Thank you for your attention.